Have you ever wondered how electronic devices work their magic? From the smartphones in our pockets to the computers on our desks, these marvels of technology rely on a vast network of components working together in perfect harmony. Among these electronic workhorses, resistors often go unnoticed, quietly playing a crucial role in shaping the flow of electricity. Resistors, in essence, are the traffic controllers of the electrical world. They are passive components, meaning they don't generate or amplify electrical energy. Instead, they impede the flow of current, like a dam regulating the flow of water in a river. This ability to resist the flow of electrons is what gives resistors their name and makes them indispensable in countless electronic applications. Imagine a world without resistors. Electrical circuits would be chaotic, with currents surging uncontrollably, leading to short circuits and malfunctioning devices. Resistors bring order to this potential chaos, ensuring that the right amount of current reaches the right components at the right time. In this exploration of resistors, we'll delve into the fundamental principles that govern their behavior, explore the different types of resistors and their unique characteristics, and uncover the myriad ways they shape our technological landscape. To understand how resistors work, it's helpful to visualize electricity as a flow of water through a pipe. The water represents the flow of electrons, or current, and the pipe represents the wire or conductor. Just as a narrow section in a pipe would restrict the flow of water, a resistor acts as a bottleneck in the electrical circuit, limiting the flow of current. The amount of resistance a resistor offers is measured in ohms, named after the German physicist Georg Simon Ohm. The higher the resistance, the more the resistor restricts the flow of current. Think of it as increasing the size of the dam in our water analogy. A larger dam would significantly reduce the flow of water downstream. But what exactly causes this resistance within a resistor? The answer lies in the material from which the resistor is made. Resistors are typically constructed from materials that are poor conductors of electricity, such as carbon, metal films, or metal oxides. These materials, unlike good conductors like copper, have fewer free electrons available to carry the electrical current. When electrons encounter the resistance material, they collide with the atoms in the material, losing some of their energy as heat. This energy loss translates into a drop in voltage across the resistor, effectively reducing the flow of current. The relationship between resistance, current, and voltage is elegantly captured by Ohm's law, a cornerstone of electrical engineering. This fundamental law states that the current flowing through a conductor is directly proportional to the voltage applied across its ends and inversely proportional to the resistance of the conductor. Mathematically, Ohm's law is expressed as I equals Vi divided by R. This simple yet powerful equation allows us to calculate any one of these electrical quantities if we know the other two. For instance, if we know the voltage across a resistor and its resistance, we can easily determine the current flowing through it. Ohm's law is like the traffic cop of electrical circuits, ensuring a smooth and predictable flow of current. Just as a traffic light regulates the flow of vehicles at an intersection, Ohm's law governs the relationship between voltage, current, and resistance, preventing electrical chaos. Resistors come in a dazzling array of shapes, sizes, and materials, each tailored to specific applications and power requirements. Some common types of resistors include carbon composition resistors. These are among the most common and inexpensive types of resistors. They're made from a mixture of carbon particles and a binding material, molded into a cylindrical shape. Carbon composition resistors are suitable for general-purpose applications, but have a wider tolerance range, meaning their actual resistance can vary slightly from their stated value. Metal film resistors. These resistors offer higher accuracy and stability than carbon composition resistors. They are made by depositing a thin film of metal onto a ceramic rod. Metal film resistors are commonly used in precision applications where tight tolerance is crucial. Wire wound resistors. For high-power applications, wire wound resistors are the go-to choice. These robust resistors are made by winding a length of resistance wire around a ceramic core. Wire wound resistors can handle significant amounts of current without overheating. Variable resistors. Unlike fixed resistors, variable resistors allow us to adjust the resistance value. These resistors, also known as potentiometers, are commonly used in volume controls, dimmer switches, and other applications where we need to vary the amount of current flowing through a circuit. Each type of resistor has its own set of advantages and disadvantages, making it essential to choose the right type for the specific application. Factors to consider include the required resistance value, tolerance, power rating, and environmental conditions.